thank you so much. Sorry, everyone, about the technical difficulties. Okay, so yeah, today I'm going to be presenting generative agents. Can go ahead and go to the next slide. I don't know if that button, if everyone can see it. Oh, that's just me. Okay. Yeah, so on the agenda, I'm going to talk about what is a generative agent, and then agent behavior and interaction. And then I'll go into detail on the generative agent architecture. Um, and then we'll talk about the results and future work in related directions. So next one. Okay, so the idea behind a generative agent, like humanity has long envisioned sort of in sci-fi movies and stuff like that, of this idea of like a computational agent that can simulate believable human behavior. You can go ahead and go to the next slide. Yeah, I think if you click again. Yeah, so there's a lot of different simulations or use cases for simulations, like an accurate simulation of human behavior. One of those would be like a model human processor. So if you have a good human, a simulation of a human, you could sort of model how humans think and get a better idea of cognitive processes. Another one is like virtual world NPCs. So you have video games like The Sims, and I mean, pretty much every game out there has NPCs that you interact with. So you could have more human NPCs. And then also social simulations. So if you have accurate simulations of human behavior, you could model social simulations such as like psychology settings or different things to get a better understanding, or even like train models. Like I know there's idea now of training models with social simulations to have them be better at interacting with people. Okay, next slide. Yeah, so there have been some attempts at simulating human behavior. Like past attempts are like these rule-based NPCs. So if anybody's ever played The Sims, or like any game with an NPC that you can talk to, you can pretty quickly figure out that they have these sort of like rules that they follow. And if they get outside of those rules in any way, then they're not going to perform or simulate human behavior at all. So as soon as you get outside of those rules, they quickly degenerate. And then there are also these like cognitive architecture NPCs, which are like there's this a lot of games have these agents which they do perceive their environment, and they take in information about their environment, but they're still inherently rule based. So instead of just like rule based by dialogue, they have rules in the environment, so they can interact with the environment and perceive the environment, but they're still limited. Okay. Yeah. So the idea with generative models to sort of do this same simulation of human behavior is that language models are trained on the internet, which are data from the internet. So text and image data from the internet, which is basically all evidence of, or how should I say this? Like a smaller subset of human behavior. So the idea would be that an LLM can sort of learn this simulated human behavior from all of this data from the internet. Yeah, cool. So there are some, there is evidence that LLMs can do this sort of like simulation of human behavior. So in this paper, Social Simulacra, they essentially take a bunch of or they create these like simulations of a Reddit community where they have, like you can see at the top, they have this community description. So the community on the left is newbies in personal finance, to ask questions in a judgment-free zone. And then they create these personas that they put into these communities, and let them interact with each other. I think you can go to the next slide. Yeah, and with these simulations of Reddit communities, they do this study where they look at um, the crowd worker. So basically, they have crowd workers simulate the Reddit conversations, and then they compare those with the actual like LLM simulated Reddit conversations. And they have human evaluators evaluate which ones are, well, essentially they in the study um, they have humans try to discern which conversations are generated or which conversations are created by either crowd workers or the LLMs, as compared to like real Reddit um, conversations. And you can see if you look at the M's in the left hand columns, then you can see that on the crowd workers, the error rate, like the M's are essentially the error rates that the human evaluators found. So with the crowd workers, the error rate was 32%, and with the uh, simulations, the fully simulated Reddit posts, the error rate was 41%. So what that means is that human evaluators had a harder time discerning which Reddit posts were real or fake, with the simulated ones versus with ones that crowd workers created. Okay. Yeah. So the paper I'm going to be talking about today, for the most part, is this one, which is called Generative Agents, Interactive Simulacra of Human Behavior. Essentially, in this paper, just as like a broad overview, they're creating 25 generative agents, and they're putting them in this sort of like Sims-like simulation and having them interact with each other just to sort of study if LLMs can accurately simulate human behavior. And if they can, what sort of things, like interesting things they can find from this. Okay. Yeah. So, what is a generative agent? A generative agent is a novel agent architecture that remembers, reflects, and plans based on constantly growing memories and cascading social dynamics. So, in this paper, they have these 25 generative agents. You can see those on the left. They're represented by these little sprites. And all they're doing is giving a background like summary for each of the agent. So at the start of the simulation, they give each of the agent a sort of like this one is human written, but it's just a background summary of who the agent is, what their relationships in the community are with other agents, and sort of like any interests or brief overview things. And this is all the agent gets at the beginning. So you can see one of the summaries for one of the agents, John Lynn, on the right. Um, so they just talk about it a little bit here. Basically, John Lynn is a pharmacy shopkeeper. He loves to help people. And they also talk about his relationships. So he's living with his wife, May Lynn, and his son, Eddie Lynn. And just a little bit of background. But this is all the agents see at the beginning of the simulation.
Alex, were there any principles behind writing these, or I guess, what was the starting point? How did they decide what kind of relationships they're going to specify through this description?
Yeah, so there's 25 agents, and I mean, part of this study is they wanted to see if agents would build relationships throughout the simulations. So I don't think they didn't start with everyone having a relationship with another agent in the simulation. So at the start of the simulation, a lot of agents will not know each other. But essentially, I think they just wanted sort of like a diverse subset of agents that had like different jobs, different occupations, different interests, and were living in different things. So some of the agents are living with multiple people in their household. Some of them only have like one person in the household.
Okay. So
Yeah.
they do start with some set of occupations, and I guess they sample pairs of people which will have some relationship, and then they have a predefined set of relationships too.
Yeah. Yeah. To start with.
Okay.
Yeah.
I also have a question. I don't know, maybe
Mhm.
you'll get to this, but is there a notion of time for these agents? Like,
Yeah. Yeah. I will get to that, but essentially, there's just these. I think they call them ticks or something. So yeah, maybe on the next slide actually.
Uh-huh.
Oh, never mind. Sorry. Well, on one of the slides, I'll talk about it, but basically, there's this idea of time that they have where will I have the slides pulled up here, but they have like a tick. So they do a generation on each of these like time steps, and then they have a certain amount of time steps for the day.
Okay, okay. Yeah, thanks.
Yeah. Okay. Yeah. So this is the Smallville world where the agents interact. On the bottom right, you can see one of the houses, and this is where I think John Lynn and his family live. So in this house, there's a lot of different items. So essentially, the Smallville is the root node, and then you have a house, which would be like a leaf node, and then there's or a child node, and then there's all these leaf nodes that are like the bathroom, the kitchen, the common room, and inside of those, there's different items, and the agents can interact with all these items as if and in like a natural language way, and then the model, the architecture that they built in this paper allows the agents to sort of like interact. So if you generate some natural language that asks to do something, then the model will actually execute that. So the agents will actually be doing that thing. So like if you want to take something out of a fridge or sleep in a bed, for example, like those are things that are possible for the agents to do. Cool. Uh, is it? Oh, maybe my screen is zoomed in. Okay. Yeah. So, yeah, like I was saying, the agents can interact with their environment. So, like in this example, you have a natural language statement that the one of the agents is generating, which is Isabella Rodriguez is drinking a coffee, and this is actually translated into concrete movements in the environment. And you can see if you look at the emojis above Isabella Rodriguez's, this is actually the model. So for each time it generates like an action for the agent, it also will generate a pair of emojis that it uses to like represent that action. And then those will always be displayed over the agent's head while they're doing the things in the environment.
What
But yeah, like I said, a bed can be occupied when an agent is sleeping, and a refrigerator can be empty when the agent uses up the ingredients to make breakfast. So they influence the state of objects in the world.
what's the point of the emojis? Like, why are they displaying with them?
I think it's just a nice way to visualize. Like uh, later on, you'll see like a full simulation, or I have a link to like where you can actually look at the full simulation. And if you were trying to like follow what each agent is doing, it'd be really hard if they didn't have these emojis because they're not like it's not like obvious when they're doing actions. I mean, you don't see them like taking something out of a fridge. It's just like they might be standing by the fridge.
Got
So,
it.
like, are these emojis for us as observers or for
Yeah,
other agents as well? Oh, okay,
yeah.
just
For observers, yeah, yeah. So the agents interact with each other through natural language dialogue. Here's an example of one of the dialogue things. So this is Isabella and Tom talking about like an election where this guy, Sam Moore, is running for election. So Isabella says, I'm still weighing my options, but I've been discussing the election with Sam Moore. What are your thoughts on him? And then Tom replies, to be honest, I don't like Sam Moore. I think he's out of touch with the community and doesn't have our best interests at heart. So they can have like conversation tit for tat. And we'll go over the how they do the dialogue later. Cool. So yeah, just to get more of an idea of what's going on here, just go like briefly go over a day in the life. So this is like the Lynn family that I talked about before. So you can see like they have a morning routine. Basically, they wake up, brush teeth, take a shower, cooking breakfast, and then at the end, you can see that John Lynn and Eddie Lynn are having a conversation, and then they pack up and go to work. So John Lynn will actually move out of his house and go to work where he works. I think he works at the pharmacy or something like that. But you can see like this is all happening on a timeline on the bottom there. Yeah. Yeah. So this is just an example conversation between John and Eddie where they're talking about what they're doing today in the morning. So the keys here are that John asks, "What are you working on today?" because he knows about Eddie's background, as like Eddie's his son in this simulation. And then Eddie tells him that he's working on a new music composition for class. So yeah, they have like dynamics and stuff. Yeah. Yeah. And then this is later on in the day. So this is May, John's wife, talking. And then John actually mentions the music composition that Eddie talked to him earlier about. And then May says, "Oh, that's wonderful. Tell me about it." So this is how like information can diffuse through the simulation. So basically, like May didn't know about this music composition before, but now she knows about it without talking directly to Eddie, because it passed through John. So that in that way, information can diffuse through the society. Yeah, that's basically what I just talked about. Um, yeah, and this is another example of that where this guy Sam is running for mayor, and he talks about how he's running for mayor in the upcoming election. And then later, he talks to this guy Tom, and then later John and Tom. So John is a completely different agent, but he brings up that he heard Sam Moore is running for mayor in the local election, where he heard about this from a completely different source, and then him and Tom can talk about the election since the information diffused. But at the beginning of the simulation, like Sam was the only one that knew he was going to run for mayor in the upcoming election. But the fact that these two other completely independent agents are having this conversation about that means that the information is diffusing through the society. Yeah. So the agents also form new relationships over time, and they can remember interactions with other agents. So in this example, Sam runs into this other agent, Latoya, and she says, "I'm here to take some photos for a project I'm working on." And then the next day, Sam will ask her about how her project is going. So before they didn't know each other, but now the next day they have an interaction, and Sam is remembering something that they talked about in their first interaction.
So Alex, where does this initial information come from? Like the fact that Latoya is going to take some pictures for a project?
Yeah, so that would come from the summarization at the beginning, or the agent summary at the beginning. So maybe like one of the interests that she has is that she enjoys taking photos, or she's a photographer. I'm not sure what it is for Latoya, but yeah, typically they would start with some like occupation or some interest that they have. And then we'll go over how they make a plan for the day later. But essentially they'll make a plan for the day and then like execute that plan. And that's how you'll see them like sort of do these different things, or come up with different ideas.
Yeah, thanks.
Mm-hmm. Yeah, and there's also this emergent behavior of spontaneous agent coordination. So Isabella Rodriguez, she's initialized with an intent to plan a Valentine's Day party. So from this initial prompt of like she wants to plan a Valentine's Day party, she invites friends to her party. She spends the 13th decorating for the party and enlists her friend Maria for help. And then from this, Maria asked Klaus, who was like her crush, to come to the party with her. And then on the actual day, Valentine's Day, so I think the simulation started like 2 days before Valentine's Day, um, 5 agents actually show up to the party. And none of these agents knew about the party beforehand. So these are agents that learned about the party through information diffusion. And then they actually end up showing up to the party physically. Cool. So now I'll go over the architecture of like what makes all of this possible. So yeah, basically, this is like an overview of the architecture. I'll go through each of these parts. So I'll go through the generative agent memory, and then the how they reflect and how they plan. And this will all explain like how they do these actions and how this whole thing is possible. Yeah. So the first thing I'll go through is the memory and retrieval aspect of the agents. So the agents use this memory stream, which is a database that maintains like a record of all of their experiences in natural language. And records are retrieved from this memory stream, with the relevant records are retrieved for the planning of agents' actions. And then also records are recursively synthesized into higher level reflections that guide their behavior. And that's through the reflection down there at the bottom. But we'll go over all that. But essentially, the memories are really important for like every aspect of the agent, because all the planning and reflecting is done using this memory stream. Yeah, so the challenge of specifically with memory and retrieval is that the full memory stream is really large. It becomes super large as time goes on because the agents collect more and more memories about different relationships or whatever they're doing or their daily plans. So the full memory stream can serve as a distraction for the model and often doesn't fit into the context window. Maybe with models now it would, but back when this paper came out, I think the context windows were a lot smaller. So yeah, here's an example of the memory stream. So you can see like each memory has a timestamp and then there's just different memories. So a lot of them are very basic. You can see like some of the memories on the left-hand side are like desk is idle, bed is idle, closet is idle. And then there's like Isabella Rodriguez is writing in her journal. Yeah. So when you pose a question to the model, or you can pose a question to this memory stream or a query for the memory stream, and then the retrieval system will pull out a memory or relevant memories and then use that to create a generation. So you can ask an agent a question and then it'll retrieve relevant memories. And you can see like using those relevant memories, Isabella would answer that she's most looking forward to the Valentine's Day party that she's planning at Hobbs Cafe. So if we go to the next slide. Oh yeah, sorry. Yeah, so this is how the actual memory retrieval score works. So basically they go through each of they go through the most recent 100 memories in the, oh no, sorry, that's wrong. I think that's for the reflection. So basically this is their retrieval score. So they have this recency score, which assigns a higher score to memory objects that are recently accessed. And then it just uses an exponential decay function over the number of game hours since the last retrieval. So it's not the most recent memory that was generated, it's the most recent memory that was retrieved. And then if we go on to the next. Yeah, so this is the importance score. And this one just assigns a higher score to memory objects agents believe to be more important. So I think if you click again, yeah. So there's a prompt for this one, which is basically just asking, this is the model, like this is the LLM that generates the importance score. But the prompt to the model is just on a scale of 1 to 10, where 1 is mundane and 10 is extremely poignant, rate the poignancy of the following piece of memory. And then you pass in the memory and you ask the model for a rating. So in that way, the model will rate every memory.
Good question. If the memory stream is long and now we are prompting a model to rate each memory, wouldn't this is super slow? Aren't they like maybe doing some kind of filtering of the memory, maybe by recency first? And then
Yeah, so I think they have scores for each of I think they generate the scores like when the memory is generated.
oh, I see.
So then
Okay,
there's just a memory. So they don't have to go through and like regenerate scores, like important scores for each of the memories.
gotcha. So it's not contextualized importance.
Yeah, but also I think you're right. Like they do take I think for specific use cases, they take different subsets of the memories. But like for importance, for example, or for reflection, for example, they take like the last 100 instances of memories.
Gotcha.
Yeah. Okay. And then the last one is the relevance score. Yeah. So in this one, they assign a higher score to memory objects that are related to the current situation. So yeah, basically for this one, the language model just generates an embedding vector for each of the memories and also an embedding for the query memory that you're using. So that would be like asking the agent like what it's most looking forward to, and then you get the embedding for that. And then the relevance is calculated as the cosine similarity between these two embeddings. So using those three scores, that's how they get the retrieval score for a memory. Okay, yeah, so on to the reflections. Yeah, so the challenge with this is that generative agents struggle to generalize or make inferences when they're only equipped with this like raw observational memory. So if you think about like they only have like so far they only have observations. But in order to yeah, okay, so here's a scenario, for example. So in this scenario, you ask the agent Klaus Mueller, if you had to choose one person of those you know to spend an hour with, who would it be? With only observational memory, he'll choose the person that he has the most frequent interactions with. But this person, the interactions are only in passing and are not deep. So he just like has a lot of interactions, but none of them are like meaningful. But if you actually use reflection, then the agent can recognize that Klaus is passionate about his research, and then he will choose the person who best shares this interest. So another person that does research would be the one that he would choose to spend an hour with, which I think is more representative of human behavior. Yeah. So reflections are just higher level abstract thoughts generated by the agent and they're stored in the memory system, but they're essentially treated the exact same as observational memories. So they're stored in the memorized memory stream and they're synthesized, but they're synthesized periodically, like over the all the observational memories. Yeah. So the approach to generating these reflections is to generate what to reflect on. And to do this, they look at the most 100 recent records. I think this makes sense also because they're doing this reflection iteratively. So the reflections will be in the recent records as well. So they can also look at reflections to sort of like get this iterative approach on it. But to generate the reflections, they prompt the model with given the only the information above, what are the three most salient high level questions we can answer about subjects in the statements? Uh, so the model will generate a few candidate questions, or I guess three candidate questions about the like given all of the memories in the 100 most recent records. So these questions could be something like, what topic is Klaus Mueller passionate about, and what is the relationship between Klaus Mueller and Maria Lopez? So using these generated questions, they retrieve relevant memories using the retrieval system we went over before, and then they prompt the model to extract insights and cite records. And that will be what they use as the reflections.
Okay, sorry, let me just go over this one more time.
Yeah, sorry, there's a lot here, but there's basically two stages of this. So first, they generate questions that they use to then generate, like to retrieve relevant memories for those questions, and then generate reflections using those memories. So there's like, I guess, three parts of this.
Gotcha. And the statement here refers to what we have seen, for example, here, if you had to choose one person of those, to spend an hour with, who would that be?
Yeah.
Okay.
So how do we choose for which of these statements we want to do this scenario of generating questions and retrieving information and then answering the question? Like, I mean, if we just ask him like, I don't know, what's your favorite type of coffee?
Mm-hmm.
You still do this?
Well, so the model is generating the high level questions. So the model would essentially be generating the queries to the memory stream.
I
So
guess
this prompt up here is just asking the model to generate those questions.
Yeah, but I mean, like for coffee, maybe just
Mm-hmm.
if we have that retrieval system without these extra questions, we could still answer accurately. But I mean, for who would you want to talk to for 1 hour, then maybe this process would really help a lot.
yeah.
I mean,
Yeah.
do they distinguish between these two types of statements or not?
Uh, I'm not sure I totally understand the question.
Okay, maybe I'll talk to you offline.
Yeah,
Yeah, if I may rephrase what Fatima said, maybe differently to help be on the same page.
sure.
Uh, the question is about when we go back here, where we have questions such as this one. This one requires reflection, but there
Yeah.
could be questions that are very easy to answer and don't require reflection, such as when did you wake up this morning? This
Mhm.
requires retrieving the recent memories, and then immediately the model, the agent should retrieve the time. It doesn't require reflection. So the question um, is there anything in their framework that categorizes questions or these scenarios into those that need reflection and these additional steps of computations and those that do not?
Oh, so reflections aren't done for like that would be more in the planning domain, which I'll go over in a second. But yeah, for the reflections, this is just done periodically to sort of give like basically it's like turning your observational memories into more high level thoughts. So
Okay.
they're not triggered by any specific question or any specific event. They're just generated periodically.
Okay. All right. Fatima, did I rephrase your question?
Yeah, I guess so. Yeah, thanks.
Okay, this is where we stopped.
Yeah. Yeah. Okay. Yeah. No. So here is some statements that like so this would be an example of like observational memories or different memories that the model is pulling to answer a certain question to generate a reflection. So then off of these uh, memories that the model pulled as relevant, the reflections will generate. You'll ask the model essentially to generate 5 high-level insights that you can infer from the above statements, and then they also give proof for that. So you can see like on the bottom here, they give an example where it's like insight because of 153. So this is like quoting memory 1, memory 5, and memory 3.
Okay,
And that
so
way you'll have evidence for the reflections as well.
going back to your previous scenario,
Mm-hmm.
you had to choose one person, blah, blah, blah. Uh,
Mm-hmm.
so from what I see here, correct me if I'm wrong, but it seems like the question there is a question that the agent might get in the interaction, and by getting this question, the agent could then trigger the reflection. But that is not what's happening. Rather, periodically, the system will uh, have, I don't know, create statements about this particular agent, and then do this extra stuff.
Yeah, it'll create questions for the agent to reflect on, essentially.
Gotcha. So,
So
okay, there isn't like agent to agent interaction that causes reflection. Rather, it's implemented in the system that to kind of poke the agent to self-reflect on certain things.
yeah, at least this reflection. There is some stuff in planning that is sort of like where an agent can trigger the another agent to do some sort of self-reflection for, but it's more for like dialogue purposes or planning.
Okay, okay.
Yeah. So here we can see like how these reflections can sort of like iteratively grow more and more complex. So in the bottom left, you have these two observations about Klaus Mueller reading about gentrification and reading about urban design. This um, is turned into a reflection that Klaus spends a lot of time reading, and in combination with a bunch of other things of him reading like research stuff, then that reflection turns into a reflection that he's engaging in research activities. There's some other reflections that are made here on different stuff. So like essentially they determine that Klaus Mueller is dedicated to research and he's well, I guess it's the same thing twice, but the high level reflection on all of these reflections is that Klaus Mueller is highly dedicated to research. So you can see like as they continue to iteratively do these reflections, they kind of like grow in uh maybe not complexity, but they grow in like how high level of a thought it is. Or at least that's the idea behind the reflections. Yeah, so next we'll go on to planning. Yeah, so the challenge here is that like a large language model can generate plausible behavior in response to situational information, but agents also need to plan over a longer time horizon. So I think there's an example if you click. Yeah, so in this scenario, a model is prompted with Klaus's background, the time is described, and you ask what action you should take. So say it's around lunchtime. Without planning, Klaus will eat lunch at 12, and then again at 12:30, and again at 1. But if you have some sort of planning system for long-term planning in place, then Klaus will have lunch while reading at 12, and then he'll work on research at 1 and continue on in that way. So he'll actually have like a logical plan for his day. So yeah, essentially plans are a way of describing a future sequence of actions for the agent that are stored in the memory stream. So these are also in the memory stream. And what they include is a location, a starting time, and a duration. I think I have an example here. Yeah, so for Klaus Mueller, he's dedicated in his research and has an impending deadline. So one of his plans might be to choose to spend the day working at his desk drafting his research paper. So a plan, here's an example plan down here, is like for 180 minutes from 9 a.m. On February 12th at Oak Hill College dorm, Klaus Mueller's room, desk. So you can see like this is the broad area, Oak Hill College dorm, and then Klaus Mueller's room is like the children node, and desk is like the actual leaf that he's going to be doing this at. And then he's going to read and take notes for a research paper. That's what that action is going to be. Oh, well, I messed that animation up. Okay. So the approach here is first of all to create a plan that outlines the day in broad strokes. So at first they just prompt the LM with the agent summary description and a summary of the previous day. So you can see that summary here. And then at the bottom, you can see the last sentence. It just says like, here is Eddie's plan today in broad strokes. So what the model sees is like information about his previous day and then information about his like summary. Yeah. So here's how they actually recurse this down to like minute to minute plans. So they have these like initial large chunk one that's generated from the prompt before for the whole day. And then they break this into hours. So they ask the model to break it into hourly summarizations or plans. And then they break these hourly plans down further into 5 to 15-minute plans. And the authors say in the paper, like they could continue to break this down more if they needed to, but they end with like 5 to 15-minute plans.
Do they use any planning algorithm, or is this just the prompting LLMs by giving initial context and then prompting to refine it to hourly and minute-wise plans?
Yeah. It's the latter. So they're just prompting it to break it down. So like you can see for 5 here, like in the large chunks, it says to work on his new music composition from 1 p.m. to 5 p.m. So like breaking that down in the hourly one, then it's just like this is the model just saying like, okay, how would you break this down? Basically start by brainstorming some ideas for his music composition at 1, and then at 4, take a quick break.
Yeah.
And then they break that down further. So when he's taking his quick break, he grabs a light snack, takes a short walk, and then takes a few minutes to clean up his workspace.
Got it.
Do
Yeah.
do they have procrastination?
Probably. I mean, if the model is good enough. Yeah. So I think we can, yeah. Yeah, so they can also react to other agents, and this is kind of like what I think you guys were getting at before, and update their plans. So basically, for the reaction, they get this like summary description and like the scenario. So John is back home early from work. The observation is that John saw Eddie taking a short walk around his workplace. So then the retrieval summary summarizes the relevant context from John's memory stream. And then you just prompt the model with should John react to the observation, and if so, what would be an appropriate reaction? So
sorry,
sorry.
can you repeat what triggers the replanning? I mean, okay, here is a status. I see observation, and I understand why observation would trigger the
Hmm.
planning, but in the actual implementation, is is yeah, is the system doing considering replanning every time it would observe something, or if not, like when does it decide to?
Yeah, that's a good question. I can't remember exactly what triggers it. I think it's
No worries.
yeah, I forget exactly what triggers it. I think it's just um like if there's I think it's each observation actually. Like when there's an observation that the agent gets, then this question is asked. So
Mm.
like you can see the question is like, should John react to the observation? So
Mhm.
like say it's just something menial that's like doesn't require a reaction, then there would be no reaction.
Got it.
Yeah. Yeah. So in this context summary, basically the questions that are given are what is observer's relationship with the observed entity, and observed entity is the action status of the observed entity. So like it'd be what is John's relationship with Eddie, and Eddie is taking a short walk around his workplace. So these would be the queries to the memory stream that we talked about before. So that's what it's using for retrieval to get these memories out. Yeah. So say the output would be that John could consider asking Eddie about his music composition project, given that this is an affirmative and that he should react to the observation, then you would regenerate the agent's existing plan starting from when the reaction takes place. So yeah, oh no, that was it for that. Yeah. So the dialogue is another thing that's sort of related to this. But basically, for the dialogue, the generative agent's dialogue is conditioned, or they speak to each other by conditioning their utterances on their memories about each other. So it's sort of a similar process. You can see like the observation has a summary of the relevant context. And then the question is, what would he say to Eddie? So, say he generates this dialogue that he says to Eddie, then he would actually say this to Eddie, and then Eddie would in turn retrieve and summarize his relationship memory about his relationship with John and any memories related to John's last dialogue. Yeah. I don't know if I have time for the results.
Sorry. Yeah, I think it would be good to wrap now.
Yeah.
Sorry, but I have to go. That's the bottom here. So maybe let me see. We probably have a lot of slides here. Can you maybe just then summarize what are the main results out of this? Would that work?
Yeah. So basically, like the biggest thing is that they do this believability study. Maybe if you just go a few slides forward, one more. Yeah, this one. Oh, yeah. So one back. Yeah, that one. Yeah, so basically the big thing here is that they show that their full architecture can outperform human crowd workers in a believability study. So they had human crowd workers like generate basically they did these interviews for the agents and they had human crowd workers try and like mimic those, but the when people actually evaluated these interviews, they found the full architecture of the generative agent thing more believable than actual human crowd worker generations. And then the other big like takeaways from this are that agents have like a lot of flaws. So they can hallucinate to embellish their memory, and they can fail to retrieve certain stuff. But on a whole, like they still end up being pretty believable as humans. And also, there's some other things that they show where it's like the agents are way too polite, and they think this is because of like the RLHF of models. Like agents are very polite, very formal. Like there's instances where someone's wife will talk to him like very formally all the time, or like the generations will be very polite. So like no one will ever refuse to do anything or like lie or yeah. So in that way, like the models sometimes fail to like simulate human behavior because they're being too formal and too polite about everything. Yeah. And there's also, yeah, I talked about a lot of the agent coordination and information diffusion stuff before, but there's like these emergent social behaviors that they find as well, which are that basically agents can coordinate, they can form relationships, and they can diffuse information throughout their societies.
All right, maybe we can finish with this future stuff. I know this is very expensive, right? Like just running in
Yeah,
the sandbox.
yeah. So that's a lot of like the future work that they talk about is that there could be more cost-effective architectures because the 2-day simulation that they do costs like thousands of dollars. Also, other stuff like building upon the retrieval mechanism to make it a bit more complex because it does miss retrievals a lot of the times. And I think it's sort of basic if you really look at it, but yeah, also better evaluations of their generative agent human simulations. So like more holistic evaluations of the human simulations, because as they say, there's a lot of flaws, but they don't really have like a concrete way to evaluate the flaws other than having human evaluators compare it to like crowd workers. And then expanding the generative agent architecture to other mediums, like other than this like Sims simulation. So like I talked about before, there's a lot of other settings where this could be used. So yeah, that's another future work.
Awesome. Well, let's thank Alex. My one clap.
Thanks, Alex.
Yeah,
Thank you so much. Do we have a paper for the next time? Did we
I
choose?
was thinking about this generative agent simulations of 1,000 people. It's by the same author, and essentially they're yeah doing a simulation with 1,000 people, but it's a little different from this, the environment that they make in this. So I think that would be maybe a good paper to do.
Yeah. Okay. I will put it on the website and share the rules very soon. And everyone, the paper link here is the one we are going to discuss. So you can start reading.